All right, in this last section of the unit, we're going to go over naming for halogens and more prefixes. Halogens can also be substituted or substituents on the main chain of organic compounds. They're indicated as a prefix in the name and follow the same rules as all of the other substituents. So a fluorine would be fluoro, chlorine substituent would be chloro, bromine substituent would be bromo, and iodine substituent would be iodo. And they have the formulas that you would expect from their element symbols: FCl, this is an L, Br, and this is a capital I. All right, so here's example 1. Identify and name the main chain. So the main chain is pretty straightforward here because we've just got one chain of carbons. It's just this right here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, which we know is pentane. Once we've identified that main chain, we just have to number the carbons. We can see this fluorine is closest to the left side, so it's pretty straightforward to start numbering closest to that F. 1, 2, 3, 4, 5. Of course, if we started here, we'd be further away. This would be a 4 instead of a 2. So we want that lower number. Now let's identify and name the substituent. So the substituent right here is a fluorine. It's a fluorine, so we would call it fluoro. So as you see here, it is a fluorine substituent. In the naming of it, though, we would say fluoro. What carbon is that substituent bonded to? Well, we can easily identify here it's bonded to carbon 2. So it's bonded to carbon 2, and once we know that, we can just write the name. So 2-fluoropentane. Right, the fluorine becomes fluoro in our name, and so we have 2-fluoropentane. All right, so here's a summary of each of the parts that we needed to determine in order to name the molecule 2-fluoropentane. All right, here's example 2. We have to identify and name the main chain. Again, we don't have any carbons coming off of this main chain, so it's pretty straightforward to identify right here. There's a carbon here. 1, 2, 3, 4, 5. So there's a carbon here on this end and a carbon on the other end, right? So we have 1, 2, 3, 4, 5 carbons, which is pentane. Once we've identified the main chain, we've got to number the carbons, and this one's pretty easy because the first, the fluorine here is on the end carbon, so we've got to start there. So 1, 2, 3, 4, 5. So the numbering starts from the left since that side is nearest the substituent, nearest that end carbon. All right, so now we need to identify and name the substituent. So we have two different ones. We have F, so we have fluorines, 2 fluorines, which we'll call fluoro, right? And 1 chlorine, which we'll call chloro. All right, so we've identified in orange the fluorines and in green the chlorine. And it's just important to note here that these substituents can be on the first carbon or the last carbon in this case. When the substituents were carbon chains, that wouldn't have been the case because that could have just extended the main chain. So let's determine then which carbon to which each substituent is bonded. So in orange for the fluorines, they're bonded to carbon 1 and 2, and in green the chlorine is bonded to carbon 3. All right, so the fluorine is bonded to carbons 1 and 2, and the chlorine is bonded to carbon 3. Now we name this exactly the same way. We've got to think about our alphabetical order. So C in chlorine comes before F in fluorine. So we're going to start with that one. So we have 3 chlorine, 1, 2, oh, I did that wrong. Not chlorine, but chloro, because we're naming. 1, 2, difluoro, pentane. So there's our name. It tells us it's a pentane chain that has a fluorine on carbons 1 and 2 and a chlorine on carbon 3. And here we have each of our steps summarized. For example, 2, from simply identifying the main chain all the way through finding the substituents and naming it. 3-chloro, 1,2-difluoropentane. We just saw in those previous examples that halogen substituents can be on the first and or last carbons of the main chain. If we had added a carbon to the first or last carbon in the chain, it would have just extended the chain. We would have just kept on counting, adding to our main chain. It would not have acted like a substituent. Similarly, halogens can be substituents in compounds that consist of as few as 1 carbon, and the same naming rules apply. So let's consider, for example, propane with its chain of 3 carbons, C3H8, as shown here, 1, 2, 3 carbons, and then hydrogens. If I added a CH3, a methyl group, on the first carbon, so I took this first carbon, I added a methyl group. I've now made butane, right? Because now instead of a 1, 2, 3 carbon chain, I have a 1, 2, 3, 4 carbon chain. This is butane. It doesn't become a methyl group substituted on the first carbon of propane. We wouldn't say 1-methylpropane. But if instead of a CH3 group, I put bromine here, so instead of this hydrogen, I've substituted bromine, it becomes 1-bromopropane. So this parent name here, this propane or this butane, remember, is determined by the longest number of carbons in a singular chain. 305. All right, so let's do an example with this halogen substituent. So identify and name the main chain, the longest carbon-carbon chain. Well, it's just 1 carbon right here. That's the longest chain. And the longest chain, if it's 1 carbon, we would call that methane. Number the carbons in the next step is also pretty straightforward. Let's take a look at that. To number the carbon, there's only 1, so we just number it 1. All right, step 3, identify and name the substituents. So we have 2 different substituents. We have chlorine. So we have chlorine. And we have fluorine. As a matter of formality, just because we're following the steps and the rules here, what carbon are these substituents bonded to? Well, there's only 1, so they're bonded to carbon 1. All right, the last step here is to just name the molecule, and it's going to be kind of funky, but we have 3 chlorines, right? 1, 2, 3 chlorines, all bonded to carbon 1. So the way we write that is 1, 1, 1, trichloro, and then the next one is a fluorine group, right? So we would write that as 1-fluoro, and we just to make sure we write them in alphabetical order. So the C in chloro comes before the F in fluoro. So we would write this as 1 1,1-trichloro, 1,fluoro-methane. And so all those ones just tell us that each substituent is on carbon number 1. So the thing to note here is all 4 substituents, 1, 2, 3, 4, are bonded to carbon 1. And the name here reflects that by showing 1, 2, 3 chlorines bonded to carbon 1 and 1 fluorine bonded to carbon 1. This 1,1,1-trichloro-1-fluoromethane is commercially known as Freon 11. It is an example of a chlorofluorocarbon, better known as a CFC. CFCs, like Freon, were found to be breaking down the ozone layer that protects Earth from electromagnetic radiation. They were phased out by the 1987 Montreal Protocol. Today, 197 countries have banned their use, and the ozone layer is recovering. Sometimes an alkyl group, so a carbon substituent, and a halogen group, or a halogen substituent, are equidistant from opposite ends of the main chain. So like this methyl group here is 2 away from the main chain. This chlorine group is 2 away from the end of the main chain. When that happens, we have to break the tie. Where do we start our numbering? In that case, we start the numbering from the end with the halogen group, closest to the halogen group. So in this case, we get 2-chloro-6-methylheptane instead of 6-chloro-2-methylheptane. If instead of having an alkyl group and a halogen group equidistant, we have 2 halogen groups equidistant from opposite ends of the main chain, the numbering is determined by alphabetical order. So in this case, instead of that CH3 group, I replaced it by a bromine, and in that case the numbering starts from this end, from the left side, because the B in bromine comes before the C in chlorine. So the name of this is 2-bromo-6-chloroheptane instead of 6-bromo-2-chloroheptane.